Molecular versus empirical formulas. Before we start, we need to understand that both formulas are basically helps determine the composition of unknown compounds. Basically, if we are given the formula C6H10 and oxygen 2, this is a molecular formula. Basically, it tells us that there are 6 atoms in carbon, 10 atoms in hydrogen, and 2 atoms in oxygen. Empirical basically simplifies the molecular formula, which turns to C3H5 and O. How did I get this? Basically, the common factor of the subscripts are 2. So we divide the subscripts by 2. Now, using elemental analysis, we can find out the percentage by mass of each compound of a compound. This helps us derive an empirical and molecular formulas. Now, let's say we are given the problem of, wait, let me just erase this. Now, let's say we are given the problem, a compound having 40% carbon, 6.7% hydrogen, and 53.3% oxygen, while given the compound's molar mass being 180 grams per mole. So to make this to a empirical formula, we need to understand that we need to make the percentages of each element to a mass. So we basically turn 40% of 40% of oxygen turns to 40 grams of carbon turns to 40 grams to carbon. 6.7% hydrogen turns to 6.7, let me put it lower here, 6.7 grams of hydrogen, and of course 6.7 grams of hydrogen, and 53.3% of oxygen turns to 53.3 grams of oxygen. Now, using this, we divide each of the masses by the element's molar mass. So for carbon, it's 12 point, wait, 12.011 grams per mole. Then hydrogen, 1.008 grams per mole. Oxygen being 15.999 grams per mole. Using this, we cancel out the grams. Now we're left with the moles. And now we get the moles of each element by dividing the mass with the molar mass. Now we get 33.3 mole of carbon, 6.63 mole of hydrogen, and 33.3 mole of, let me adjust this real quick, 33.3 mole of oxygen. Now, seeing this, we need to divide them by the lowest given mole value. Now, to do that, we just divide all of them by 33.3, since all of them are since the lowest mole is 33.3, we divide them by 33.3. Now we get the answers, which is 1, 2, and 1. Now, before that, we must understand that if the mole ratios are not whole numbers, which is like this, whole numbers, we multiply all the ratios by the same number to eliminate fractions. But for the sake of the simplicity of the example, there will be no multiplier for the empirical formula. Now, we get the ratio 1 to 1. These are the values of the empirical formula. This means that if we turn this to a formula, we get carbon, since it's 1, we don't have to put anything, hydrogen 2, and oxygen. This is the empirical formula of the given. Now, what do we need to get the molecular? Let me just remove all of this. Now, we have CH. Now, we have CH2. Using the empirical formula, we can finally find the molecular formula by multiplying the subscripts to the molar mass of each element. So basically, carbon, since there's only one carbon, we multiply 1 times 12.011. Then hydrogen, we have 2 times the molar mass, 1.008. And of course, oxygen 1 times 15.999. So after we get the product of all of them, we get carbon still being 12.011, hydrogen being 2.016, and oxygen being still 15.999. And we need to add them all together. We get the sum of 30.026 grams per mole. Per mole. You won't see it, but grams per mole. Now, given the 180 grams per mole of the given a while ago from the problem, we basically divide 180 by 30, the one we have. So if we divide 180, I'm sorry, let me fix this. 180 divided by 30.026, we get the final answer of 5.99, or you could just round it off and it turns to 6. This is the multiplier to apply to the subscripts of the empirical formula. And that will be our final answer. The final answer would be the final molecular formula, which is C6, H12, and O6.